Hello everyone. This is going to be a tutorial on perfect forwarding. If you're not already familiar with move semantics, I have a tutorial available for that, which I suggest you look at first, because this one is going to assume that you know how move semantics already work. As usual, this is going to be a live demo, by which I mean I'm going to do all the coding as we go along, and I have no notes prepared, so this is all just ad hoc, and I'm improvising as we go along, so it may not be completely smooth. And there are two things that I want to emphasize in my tutorials. The first is that I like them to be as intuitive as possible. So I'm going to start with basic concepts that you're familiar with, and then try to expand upon them. And I'm going to explain why we want to use this feature, not just how we use it. So we'll start off by including vector, and use the standard namespace for convenience. And we'll start off with a vector of integers. So when we have something that we know is going to expire, rather than using copy assignment to initialize v1, since we know that v2 is going to expire when it goes outside of this scope, we can be a bit more efficient, and we can use move assignment, and we'll steal the resources from v2 to create our v1 here. But let's take one step back. Let's start not by copying entire vectors, but let's just copy one value. So let's say we have a foo, and let's say foo has a lot of member variables here. So we're trying to just emphasize that foo is potentially expensive to create. So if I have a vector of foo, and I have some foo here, well, you can say, well, I'm going to push this foo into the vector. But again, we say this is perhaps a bit more expensive than we want, because this is going to make a copy of foo. And we know that foo is about to expire. So instead we could say, well, I'd like to move foo into here. Right? So we can move foo, which is a bit less expensive. And another way you could do a similar thing is you could say, well, I won't make foo an L value. I'll just make a foo as a PR value. And this is also moving a temporary foo. But even this is still not as efficient as it could be. So the problem we have here is that we're going to have a default constructor call, and then we're also going to have a move constructor call. And the question is, well, can we get rid of one of these two calls? Because ideally, I already know I have some space that v1 is using to store its foos, and maybe I can just construct the foo in that space. So to make things a bit more interesting, we are going to give foo a second constructor that's actually going to use some values. So we'll take an int I, a bool b, and a float f. And we'll use those to initialize some member functions, which we'll add in a moment. So we'll say it has an int mi, bool b, a float f. And then it still has potentially a lot of member variables, which we could also initialize, but we'll just start with these for now. So instead of doing this, we could say, well, I'm going to initialize it with 1, true, and 2. And there's 3 different types of variables here. And this one will also look similar. So again, these all kind of accomplish the same thing by creating a foo with this value inside of this vector. But we can create it in several different ways. But again, this still has this custom constructor and then a move constructor. So there's something new in the interface of vector called emplaceback. And if you look at the signature here, it says it takes value type, and then we have this double ampersand, which we saw before as our value reference. Then we have this weird ... And what I can do here is I can supply the arguments to the constructor right here in this function call. And what it's going to do is it's going to build this foo directly in the vector space. So I'm going to quickly kind of look at the definition of this function, just so you can see that it's kind of doing that, and it's a bit complicated. So the thing that I want to see to point out, so you don't need you to understand all of this, again it's quite complicated, but you can look at this comment here. It says insert by moving into element at end. So it has a pointer to the end here, and it has this forward, which we're going to look at shortly. And it's passing these values, and the values are these value types. And this is templated to take any types of values. And it's going to pass this into a constructor call, right? So it has this construct. And if we jump into this construct, and then we jump into this construct one, we can see here that it is creating the item, right? So the vector's memory is on the heap, but we're going to use a placement new. And we say, well, I know where I want to create this item. I want to create it at the position that I gave you, which was at the end here, the last, as we saw before. And we are going to call the constructor, right? So this TOI is the type. So this is the constructor for that type. And we're going to forward the arguments to it. So here, these are the arguments, this 1 true 2f, in the same way that we had this constructor call here with 1 true and 2f, except rather than creating the foo and then either copying it or moving it into the vector, we can create it directly in the vector itself, and we call that in place. So this uses something called perfect forwarding. I'm going to show you the syntax of that through a little example. So let's say we have some other class, some class bar, and bar has this vector of foo in it, but it's private. So you have some sort of function that's like add foo, and you might start by saying, well, I'll take a foo by const reference, and all I'll do is I'm going to push it into my vector, right? So this way, even though this vector is private, some people can add some information to it, right? I don't want them to be able to do other things with my vector. I just want them to be able to add something to the outside. So then erase all this, and we'll say, well, I have a bar, and I have some foo, and we'll make it our fancy foo again. Let's do first. And then I can say I'd like to add this foo to the bar. But again, this is going to copy construct it, which we may or may not want to do. So in this case, maybe it's fine. Maybe we want to keep this foo. But the bigger problem is that I don't necessarily want this foo. Like maybe I only want to create this foo so that I can put it inside the bar. So what I'd like to do is I'd like to do this kind of in place thing, right? Where I'd like to change this to in place back, but I want to give it just the parameters, right? So I don't want to give it the foo, though you could do a copy construct with in place back, but I don't want to copy this, and I don't want to move it. I'd rather just create it from scratch. So I need some sort of foo. So I'm looking to do the same thing here, and we're kind of curious, well, what's the syntax to do that? Because here this is obviously not correct. So it needs to be able to take any types, and not only any types, but any number of types, right? Because we want to be able to call, to pass the arguments of a constructor call. And there could potentially be more than one constructor, right? So I could have a constructor maybe that just takes an integer, and it'll only initialize this integer, and it won't do anything else, right? So we see we have a constructor that takes no arguments. We have a constructor that takes one argument of type int. We have a constructor that takes 3 arguments of 3 different types. So we need to be able to give this add foo function any types and any number of arguments. So you might be familiar with templates, and you're probably mostly familiar with having this kind of a single type, or maybe you have some template that has two types. But we can instead have this template that takes a variable number of types. And we do this with this triple dot notation. And this is something called variadic templates. And perhaps I'll make another tutorial about that at some point. But for now, it's enough to know that this allows you to have any number of templates, and they can be of any types. But here we're mostly focusing on the perfect forwarding. So here we have our types, any number of them, of any type. We're going to call them args. And here we saw this double ampersand, and before we called that our R value reference. But in this context, it's actually a little different, and it's called a forwarding reference. And if you've read Effective C++, or Effective Modern C++ rather, Scott Myers actually calls this universal reference. But the C++ committee prefers the term forwarding reference. So we're going to use that. And if you remember, when you use move semantics, you need to call move again on your argument so that you can continue passing it as an R value into further function calls. So here we're going to do something similar, but it's a little bit different. So we're going to have forward, and forward is templated, and it's going to be templated on our type, and it's going to take our type as the our argument as a parameter, and we need this ... to say that we're going to do it multiple times. We're going to do it one time for each of the arguments, right? So with each of the types and each of the arguments of those types, we're going to forward it into this embrace back call. And what forward does is it keeps the value type of the argument. So if the argument was an L value, it'll remain an L value. But if the argument was an R value, it'll remain an R value. And that's similar how we were using move to have something that was an R value, keep moving as an R value in further function calls. So, how does this compile? I'm not supposed to write bool, I'm supposed to write true. And yes, now it does compile. And what this is going to do is, when we run this, we can look at bar. We can see inside its vector, it indeed has one foo, and it has our values of 1, true, and 2. And instead of constructing it, I suppose, instead of constructing it like this, and then move constructing it to put it inside this vector, which we didn't have access to, we can perfect forward it by changing the signature of this call. And it takes its types either by L value or R value, because it is a forwarding reference. So again, you can think of it, so I see why Scott Myers likes the word universal reference, because if you think of a universal reference, you say, well, a universal reference could be an L value reference or an R value reference. And it'll keep it in the way that it was. So it's universal in that it can refer to both types. But we call them forwarding references more because of how we use it with perfect forwarding, rather than universal references, which is a bit more descriptive, perhaps, of what it's referring to. So we accept arguments of any type, and then we forward them to the function that we want while maintaining their type. So let's say, for example, we had a foo constructor, which additionally took a vector. And how do we want to take this vector? Let's think about this for a second. Let's do busy work. We'll take a vector int and v. We'll do it two ways, to be explicit. We'll take one by reference, and it'll copy the vector. And we'll take one by move, and it will steal the vector's resources. So let's say we have this vector of integers. And we want to use that to construct the foo. And here the vector is an L value, right? So I intend to arrive in this top one because it's an L value. So if I run this, we indeed come here. And furthermore, if I jump out of this code a little bit, after I do this constructor call, I can look at my vector, and I still have all my contents in there. So let's change that and say, well, I want to move it. And now when I run this, I end up in the constructor call that takes this vector by R value reference. And if I jump out of this, if I look at this vector now, you can see it has size 0, right? So it has no contents. Its contents were stolen because we used it in the move constructor. So with this perfect forwarding, it takes arguments of either L value or R value type, and by forwarding them, it maintains their type. And what it allows us to do is we never have a default constructor call or a custom constructor call prior to when we're actually putting it where we want it to be. Right? So we're putting it directly in place where we want it. And that'll just about cover for now. Thanks for watching.